Calculus is probably the largest section of mathematics. It takes up a considerable amount of any maths courses or physics courses or engineering courses that you may encounter. And because of that, it goes on for ages. It has many different facets and intricacies and methods and theories going back hundreds and hundreds of years. And because of this, it's a bit of a mess. But it is incredibly important. Most things, most mathematical, physical, engineering related things, most objects you work with on a daily basis run off of this concept of calculus. So no matter what you study, it's coming for you. Like if you're studying something mathematical, this textbook here is about 90% calculus. If you're studying something to do with electricity, it's all calculus, this entire book. Something in general relativity, something a bit more physicsy, the entire thing is calculus. And even quantum mechanics is almost entirely based off of calculus. So this is our problem. So what exactly is it? Why does it make up all of my horrible textbooks from university? Why does it make up everything that our world is built on? Well, first of all, we need to get this idea that calculus is split into two smaller topics. Although smaller is understatement of the century. Differentiation and integration. These are the two subtopics of calculus. So in this video, I'm going to just very quickly break down the overarching meaning of what is differentiation, what is integration. Because when it comes down to it, they both have pretty simple definitions to get your head around, but the applications of that can obviously become a little bit tricky. So differentiation has a very simple way of understanding it. And that is the fact that differentiation simply means a gradient. If I have a graph of anything, and I find the gradient of that graph, I have found its derivative. I have differentiated it. And the reason that this is such a fundamental part of maths, physics, engineering, etc., is because finding a gradient of something means to find the rate of change of something. And in the real world, most things change based on time, whether that is speed or acceleration or velocity, whether that is momentum, whether that is a stress strain of a material or energy compositions of a bridge or oscillations within a rubber band or anything. Anything goes along this idea of rate of change. And up until this point, if you're very new to calculus, you've probably just calculated gradients by using a nice triangle. But in real life, our graphs don't look like that. They look like this, they look like this, they look like this. I hope not, but maybe they do. Polar coordinates, I could probably make that work. But the whole point is they make up absolutely everything. So differentiation to find gradients are very, very important. Integration, on the other hand, finds areas, the area under a curve specifically. Once again, the area under a curve is a very, very important thing. It gives us a relationship between two variables that is often very, very important on a distance time graph, or on a velocity time graph. It all gives us information about the distance traveled or the acceleration or a number of different things. And once again, this is applicable to absolutely everything. So when it boils down to it, all we're doing with differentiation and integration is finding gradients and finding areas. But a lot of weird stuff starts happening when you look at the types of graphs that we can use. And that's why this subject is so vast. But we're going to work through it slowly. Hopefully, a video a day or every 2 days on calculus, along with something that I would consider pre-calculus. So things like trigonometry or binomial distribution, or binomial expansions, I should say, partial fractions, and just straight algebra. Everything is essentially pre-calculus. So hopefully we'll be able to go through this one step at a time, building us up to this kind of level of understanding where I can show you something random from one of these books and hopefully understand it.